This meeting is being recorded.
In Chapter 5, Problem 5, we are asked to draw all the constitutional isomers with this molecular formula here, C4H9Br. So we're going to have 4 carbons that we can arrange. We're given the hydrogens to fill in the octet, and then 1 bromine atom to place in various locations. So we are going to strategically approach this question to draw these constitutional isomers. And then we're asked to identify if any of the isomers, or more than one, possesses a chiral center. So we can arrange these 4 carbon atoms either in a linear fashion, like we see these two structures over here, or a branched orientation where we have, CHED, where we have 3 carbons in our longest chain and then our 4th carbon as a side chain. So let's take a look here. If we have our 2 linear, our 2 branched positionings of these 4 carbon atoms, we just have to fill in all of the bromine, or fill in the bromine on each structure, and then all the hydrogens to make sure we have all the possible constitutional isomers. So we could place our bromine either on the end here or on, say, this second carbon here. So we could have a 1-bromobutane or a 2-bromobutane. And then we fill in those hydrogens here and here. And then we have 3 more here. So we have 3, 4, 5, 6, 7, and then we know we need 2 more over here. So this is our first constitutional isomer. And then down here, we'll fill in where all the hydrogens need to be. So we have 3, 4, 5, 6, 7, 8. And then we see on the carbon with that bromine, we also would have a hydrogen. So there's number 9. And these are the 2 linear constitutional isomers with 4 carbons. Over here, we see some branch structures. So we could place our bromine in the middle here and have a 2-methyl 2-bromo propane, or we could place the bromine on a different atom here, and we would have a 1-bromo 2-methyl propane in this case. So we just double check. We'll fill in all of our hydrogens here. Because if we do this, this might make it a little easier for us to see if we have a chiral center. And then we'll have, so we have 3, 6, 7, 8, and then our 9th would be on this central carbon there. All right, and then we have, 3 on each. So we have 3, 1, 2, 3, 6, and then 9 hydrogens with this last one up here. So these are the 4 constitutional isomers that are possible, and you would find that if you tried to place carbons in a different bonding pattern, you would end up with some version or some orientation of these same 4 structures. So let's take a look. Do any of these possess a chiral center? So we need to locate a carbon with 4 different groups bonded to it. And let's take a look here. So this first structure, we see that every carbon has at least 2 hydrogens, so we know that this cannot be chiral. Then we see that the central carbon is 3 methyl groups, and then each of the other carbons has 3 hydrogens, so that's no good. The structure below, we come close with the central carbon, but there's 2 methyl groups, so nobody here has a chiral center, but this carbon here, if you notice, this has a bromine, a hydrogen, a methyl, a substituent on this side, and then an ethyl group on the right side here. So this would be our 1 chiral structure that is of the 4 constitutional isomers for C4H9Br.